Today's lab is the separation of a mixture. Many materials that we come across today are either pure substances or mixtures. And one of the challenges that chemists face is how to separate apart those materials. Mixtures can be separated based on their physical properties. Pure substances, however, cannot be separated. So today, you'll be taking a mixture provided to you in your lab pack and separating out 4 components. Those 4 components include sand, otherwise known as silica dioxide, sodium chloride, otherwise known as table salt, benzoic acid, which is often used as a food preservative, and then finally iron filings. As we go through this lab, keep in mind you need to take good notes so that upon completion of the lab, you can fill out and complete your lab report. Now, one thing to note about this particular lab, it may take a day or 2 to complete. There are steps where you will need to allow water to evaporate, and that can take a couple days. Additionally, there's a step where you'll need to dry off the sand, and you can do this by placing it in your oven or leaving it outside. Whichever approach you decide to take is up to you, but just keep in mind that from start to finish, this lab may take more than 1 day. To begin, please remember the most important safety rule in the chemistry lab or in your kitchen in this case, and that is to always wear your safety goggles. Today we will be using the flame, and there will be the potential for splattering, so please be careful and protect your eyes. For today's lab, there are some materials that you're going to need from your lab pack, and there are some materials that you're going to need to provide yourself. The materials that you need to provide yourself is some sort of small plate or saucer, something, a small spoon or stirrer. In this case, we have a cheese knife. You'll need some ice. The manual asks for crushed ice, but pretty much any type of ice will be fine. A couple of coffee cups, and then either small paper cups or styrofoam cups, paper towel, and then either a baggie or plastic wrap. The materials that you'll need from your lab pack include the handheld balance, the small glass beaker, a funnel, the burner and mesh, the graduated cylinder, and then the component bag that specifies or states separation of a mixture. To begin, remember, protect your eyes. The first thing you want to do is open up the bag with the mixture, filter paper, and whey boat. In this lab in particular, you need to be very careful as you handle the mixture. The reason for this is part of your grade will be based upon your ability to not only identify but to quantify the amount of each component. And if you spill or splatter or lose any of the materials, this will impact your final results. Now, as I begin to go through this lab, I'm going to walk you through some of the beginning steps, and then allow you to take it from that point forward. Of course, if you have any questions as you're working on this lab, please do not hesitate to contact me via email or call my office. Now, I cannot stress enough the importance of reading through the lab manual before you actually do the lab. This helps you become familiar with what you're doing, and in particular there may be some points or parts where you have to quickly do multiple steps, and if you're going through it very slowly, you may lose time, or you may actually allow a chemical reaction to occur where you're supposed to measure or observe it, and by the time you realize what you're supposed to do, it's already happened. So the first thing I'm going to do is I'm actually going to set up a data table in my lab manual, very similar to the one that's shown in your laboratory assistant at the back of the lab manual. Again, I'm not going to collect and look at your lab manual, but if you keep a good record of what you do, it will come across in your lab report. Okay. So following through with these steps, and again, I'm going to go through this assuming I was you, and I'm going to take my time as I go through each step. The first part of this lab is to separate out the iron from your mixture. And so to begin with, we're going to need to use our digital scale. Now, I think this is perhaps one of the coolest features of your lab pack. These balances can actually be quite costly. Though if you do have a kitchen balance, you could use that just as well. So the first thing I'm going to do is put the weigh dish on the scale and tare it, and then I'm going to empty the entire packet of the mixture into the weigh dish. Now again, this is where you want to be very careful and not allow anything to spill. Okay, I'll set that off to the side and record my mouse. Okay, so the next thing that you're going to do is pour the contents of the mixture out on a piece of paper. From here, you're going to use your iron magnet to remove all of the iron. Now, be careful. You may be tempted to simply take the magnet and just put it over the mixture. If you do this, you're going to have a hard time removing the individual iron filings from the magnet. This is why you need to use a plastic baggie or the plastic wrap. So now I'm going to pour the contents of the mixture out very carefully on the paper, and the directions say to thin it out. And I'll use the weigh boat to do that. The thinner you can make it, the better, because the easier it will be to remove all the iron. Okay. Now, the lab manual says to cut a 10 centimeter square piece of paper, and it doesn't have to be exactly 10 centimeters. It needs to be large enough to fit on the balance, or actually small enough to fit in the balance, but large enough to hold all the iron. So I'm going to use the clear plastic wrap instead of the plastic baggie, and again, it's sort of whichever you prefer to use. And you don't need to use a large piece, just something small that you can wrap them around the magnet. And then just simply, and you can see here, I'm picking up all the iron. And here's where you gotta be a little bit careful, because as the iron's popping up, the sand is shooting out. Now, I've gotten to the point where I've sort of maximized what I'm going to get, So while holding this over the mixture, in case any of it falls off, I'm going to get my paper ready. And with the paper, I am going to write down the mass of just the paper, as this is going to be easier in case the balance turns off. And I'm now going to put the magnet over the paper and carefully remove the magnet, and as you can see, all the iron filings have fallen directly on the paper. Now I'm going to repeat this process as I have a little bit more iron I need to separate. And it's okay if you brush up with the mixture in this step. And once again, carefully actually, I have made the mistake of getting some of the iron directly on the magnet. And so for this, I'm just going to use the clear plastic wrap. Now, as you can maybe see, my balance is turned off, and this may create a problem because if I had teared it, I now, when I turn it back on, it's going to re-tear. But since I wrote down the mass of the paper, I can just take whatever mass I get from the paper and the filings and subtract the paper to get the mass of the iron. So, okay. Now at this point, I am going to move the iron off to the side and move on to the next step, which is separating out the sand. So at this point, I'm going to take the mixture and what I have and carefully pour it into the 50 ml beaker. And I'm going to add 50 ml of distilled or tap water. Throughout your manual, it often will refer to distilled water. And to be quite honest, using bottled water or tap water will be just fine. So, when you measure this, there's two ways you can go about measuring it. One, you can use your 25 ml graduated cylinder, measure 25 ml twice for 50 and pour that in. Or, you can just measure up to the 50 ml line in the beaker. One thing to point out is beakers are actually not the best way to measure volume. There's a lot of potential error. Although there's graduated marks on here showing different volumes, the amount of error is quite large. Usually it's anywhere from plus or minus 5 to 10%. So what does that mean? Well, if there's 5% air in this beaker, although it says up here 100 milliliters, it could actually be 105 mils, or it could be 95 milliliters.
Okay.
The next part of the directions say to measure 50 mils of water. Now, there's one of two ways you can do it. You can use a graduated cylinder, which is a little bit more accurate, just based on how they are made, or you can measure it directly into the beaker and measure up to the 50 mil mark. In this case, since the actual volume is not that important, we can just simply use the beaker. So I'm going to pour approximately 50 mils into the beaker. At this point, what we have left in our mixture is benzoic acid, sodium chloride, and the sand. Benzoic acid and sodium chloride are both soluble in water. So those are dissolving, and what's left behind is the sand. So at this point, you do need to set up your burner. And again, be careful. Again, I recommend removing any tablecloth or anything else. And in this next step, we are going to boil the water and occasionally stir in it, and this is to make sure that all the sodium chloride and all the benzoic acid has dissolved. At this point, you can see that my water is boiling quite strongly. The best thing to do is not to grab the beaker, but simply to move the beaker away from the heat. I guarantee if you try to reach on for the beaker, you're going to burn yourself and possibly drop the beaker. As you can see, once I removed it from the heat, the boiling subsided and we're pretty good. Now at this point, I'm going to leave the flame going because we still need it. But you're going to create a small ice bath using a coffee cup, a little bit of ice, and some water. And using your other coffee cup, you're going to place that into the water bath. Now at this point, it talks about using a method called decanting. And what this is removing the liquid and keeping the solid in the beaker. Now, again, I let this sit for a little bit so it cools, so you can touch it with your hands. And that's still a little bit hot, so I'm going to let it cool for a little bit longer. When you decant, you want to carefully remove the liquid, but keep the solid behind. So the stirrer can actually help you to remove the liquid, but keep the solid. So you're going to want to pour it out of the lip of the beaker, and you want the stirrer to sort of rest right there in the lip. And I'm going to pour this slowly directly into my coffee cup ice bath. And again, if you're worried about if this is too hot, or if you're worried about sand making its way in, pause, stop for a minute. Again, there's no rush. Take your time. And actually, what's interesting is I can already see it forming on the stirrer. The benzoic acid is precipitating. Now this will definitely occur in the bath. But as you can see, it's also happening on the beaker and on the stirrer. So as you can see, we have a little bit of water left, and on the side of the beaker you see some white residue. That white residue is the benzoic acid. If you also look in your ice bath in your coffee cup, you'll notice that in the coffee cup you'll see a liquid, and you'll see some solid or particulate matter sort of floating. And again, that's all benzoic acid. At this point, what we want to do is to get all the salt and benzoic acid in the styrofoam cup and have only sand left behind in the beaker. Now this may take a bit of rinsing, and it's fine if it takes multiple times to do that. The thing to keep in mind is the more water you use, the longer it's going to take to evaporate out to separate the sand, or I'm sorry, separate out the sodium chloride. But that's fine. The key goal of this lab is to be very analytical and to measure the specific amount of each of the 4 parts. So, in my opinion, if it takes a little bit more water to get all the benzoic acid, then that's fine. So again, I'm going to add a little bit more water to this to sort of, particularly the edge here, to rinse it. And then again, I'm going to carefully decant. I don't want the sand to go, I just want the benzoic acid. Now at this point, you can see that we have some sand in here. At the moment, I still have some more benzoic acid, so I would probably want to continue filtering this out. For the rest of this video, I'm going to give you some tips on how to complete it. Again, the purpose of these videos is not for me to completely demonstrate the entire lab, but to assist you with some key parts that may be difficult or just require a little extra attention. If we assume at this point we have the coffee cup with benzoic acid and sodium chloride, and over here we have the beaker that has just sand in it, the directions say to use your burner to dry out the sand. You can definitely do that. The one downside to using the burner is it may cause the sand to splatter, and it may splatter out of the beaker. What I recommend doing is perhaps putting the whole beaker in the oven at a very low temperature to evaporate off all the water. Once that's done, you can very accurately measure the amount of sand. But again, if you put it in the oven, low temperature, you don't need to have it up that high, and make sure you keep an eye on it. You don't want to let it sit for hours and hours and hours. Once that is done, so we'll move this out of the way, what you have left is the benzoic acid and the sodium chloride. To separate these two, you're going to use filtration. And the filtration involves using a funnel and filter paper. And with the filter paper already comes folded in half. To properly use the filter paper, you're going to fold it in half one more time and then sort of fan it out. And when you do that, you have a liner for the funnel. Now the funnel you can place in the beaker or another small vessel. Whether it's what's provided to you in your lab pack or something you have at in your home, either one is fine. The goal here at this point is to pour the liquid through the funnel. The benzoic acid is going to be caught on the filter paper, and the sodium chloride the dissolved sodium chloride is going to go straight through into whatever container you have. Now, for example, this coffee cup wouldn't work because the funnel will just drop in. You could use the graduated cylinder, but the problem is it can't hold much of a volume. So you may want to wait until you're done with the beaker from with the sand, or again find a container similar in size to the beaker to do this step. Now you'll notice here that as I let go of this, the filter paper shoots up. And actually all you need to do to keep that from happening is to pour just a small bit of water or of your solution into the funnel. Once you do that, you'll notice that the paper stays in there fine. Now it may take a little bit. You can see I've poured a little bit of the solution in there. It may take a little bit before it starts dripping out. So this could take a couple minutes or even as much as 15 or 20 minutes to complete. But once you're done, what is in the filter paper is benzoic acid, and whatever is in your container is the dissolved sodium chloride. To complete the lab, you need to let both the filter paper and the solution sit out for a little bit so the water can evaporate. Once the water's evaporated off the filter paper, you can weigh that to figure out your benzoic acid. Once you've allowed the water to evaporate out of whatever container you're using, what will be left is sodium chloride. Now again, the lab manual talks multiple times about weighing that final product, whether it's the iron, the benzoic acid, the sand, or the sodium chloride. Remember, whatever container you have them in, you need to weigh the container before you put anything into it, and then weigh the container with whatever the material is. So if I wanted to use this graduated cylinder for the sodium chloride, I need to have weighed it first before I did this, and then weigh it again after all the water is evaporated, leaving behind the sodium chloride. The difference in those weights is the amount of sodium chloride that I have. So with that, I hope you have good success with this lab. It's a very tricky lab because very small mistakes can lead to some error, and that's okay. Just make sure you document parts or areas where you believe you may have some error. Perhaps you saw some of the sand splatter out when you were heating it, or maybe you spilled some of the solution as you were pouring it into the funnel. Again, as long as you document where your error is coming from, you'll be fine. So with that, good luck on this lab. If you have any questions, please let me know. Thanks.